Alright, notes number 2, dividing monomials. So we're going to look at 3 different rules today. So yesterday we looked at multiplying monomials, so today we're going to get into dividing monomials. So our first problem, we have 5 to the 5th divided by 5 to the 2nd. If we write this out in expanded form, it's going to be 5 times 5 times 5 times 5 times 5. There's going to be 5 of them, and then 5 times 5. So that's expanded form. Now if you notice, well, these can cross off. And these can cross off, and we're going to be left with 3 5. So exponential form is 5 to the 3rd. When you look at number 2, we have 10a to the 4th divided by 2a. Well, if I write it in expanded form, I have 10a times a times a times a. I have 4 a's and 2 times a. Well, I know that 10 divided by 2 will give me 5. And then 1 sets of a's cross off. So I have 3 left, so that's going to be 5a to the 3rd. And then the last one, we have 2c to the 5th, so that's 2 times 5c's divided by 4c to the 3rd. So we look at our number, well, 2 and 4, well, 2/4 really simplifies to 1/2. So we have 1/2, and then with our c's, well, these cross off, these cross off, these cross off, so we have c to the 2nd, and they're in the numerator, so I'm going to put my c to the 2nd in the numerator. So that's the exponential form, is 1c to the 2nd divided by 2. So our key concept, our quotient rule, is when we're dividing two powers, we subtract the exponent. So when we're dividing powers with like bases. The like bases are the a's or the numbers that were the same. The first one, all of them had 5s, and then we had our a's that were the same and our c's that were the same. So dividing powers with like bases, the rule here, what we're really doing is when we cross these off, we're really just subtracting the exponents. So when dividing powers with like bases, we subtract the exponents. So what that means is, so if I have a to the m divided by a to the n, it's going to be a to the m minus n. Or another example would be if I have a to the 5th divided by a to the 2nd, it's going to be a to the 5 minus 2, which equals a to the 3rd. So that's our quotient rule. When we're dividing exponents, we want to subtract them. So if we look at a couple of these examples here, now we notice in number 1, the exponents are the same. It's 3 to the powers are the same. With the like bases are the same, 3 to the 5th divided by 3 to the 2nd. So we can subtract these. So we're going to get 5 minus 2, and 5 minus 2 is 3. So we have 3 to the 3rd, and we know that 3 to the 3rd is 3 times 3 times 3, which is 27. When we look at number 2, we have like bases, both of them are x's, so we're going to subtract 10 minus 5, which will give us x to the 5th. Number 3, now we have two things. We have x's and y's. Well, x's and y's, so what we're going to do is we're going to do the x's. We're going to do 6 minus 3. And y is going to give us 8 minus 2. Well, 6 minus 3 is 3. 8 minus 2 will give us 6. So we have x to the 3rd, y to the 6th. Now number 4, well, 5s are like bases, so we can subtract the exponent. So 4 minus 3, and then a's, so we do 9 minus 3, and 4 minus 3, so that's 5 to the 1st, and 9 minus 3 is 6, so a to the 6th. And 5 to the 1st is just 5. When we get to number 10, now number 10 is a little bit different because it has a 10 to 2. They're not like bases. Well, what we do with the 10 to 2 is we simply 10 divided by 2. That gives me 5. So we know it's going to be 5. And then we look at our a's. Well, that's going to be a to the 12 minus 6. And 12 minus 6 will give me 6. So it's 5a to the 6th. And now with number 3, we have b's, we have c's, and we have numbers that aren't like bases. So we can simply simplify 3 and 9. Well, 3 and 9 simplifies to 1/3. And then we have b 5 minus 1, and c to the 6 minus 4. 5 minus 1 is 4, so we have 1/3 b to the 4th, and then 6 minus 4 is 2, so it's c to the 2nd. So the other way that I can write this is I can put both the b and the c in the numerator, so I can have b to the 4th, c to the 2nd, all over 3. When we look at number 7, it says the following rectangle has an area of 10x to the 4th, y to the 3rd. What is the length of the missing side? Well, if we know that the whole area, so the whole area is 10x to the 4th and y to the 3rd. So we know that length times width is equal to the area. Well, I'm given my length of 2x squared y squared times our width, and that equals 10x to the 4th to the 3rd. So what we can do is we can actually divide. So we can say that the width is equal to 10x to the 4th y to the 3rd divided by 2x squared y squared. So now to solve this, we know that 10 divided by 2 will give us 5. So that's going to be 5. And we know that 4 minus 2 is 2, so that's 5x squared. And 3 minus 1 is 1, so y to the 1st. And we can check our answer by saying, well, if I plug this in here, I know that 5 times 2 is 10, x2 plus x, or times x2, 2 plus 2 is 4, and then y to the 1st, y to the 2nd is y to the 3rd. So when we're given the area and the side, we can divide those two to find the missing side. Now the next thing, negative exponents. Well, if we look at this quotient rule, what it's saying is that I can subtract my exponent. So 5 to the 3rd divided by 5 to the 5th will give me 5 to the 3rd minus 5, which will give me 5. 3 minus 5 is negative 2. Now I can do the same thing. The quotient rule, it says I'm going to subtract these. Well, 2 minus 5. 2 minus 5 will equal m to the negative 3rd. Well, we can also write it in expanded form. Well, 5 to the 3rd is 5 times 5 times 5, and 5 to the 5th is 5 times 5 times 5 times 5 times 5. Well, these all cross off, and we're left with 2 5s on the bottom, so that's really 5 squared. 5 squared as the answer. Well, nothing's in the numerator, but what we have to remember is when we're crossing these off, we're really dividing. So 5 divided by 5 is 1. 5 divided by 5 is 1. So this really becomes 1 times 1 times 1, which gives me 1. So we get 1 over 5 squared. And then if we write this out in expanded form, m times m, and then we have 5 of these. And once again, these cross off, and so when we cross them off, it really makes them 1. So 1 times 1 is going to give me 1, and I have 1, 2, 3, m to the 3rd. Now if you notice, we did the same problem, so I got 2 different answers. But what you have to understand is that 5 to the negative 2nd, it's the same thing as 1 over 5 to the 2nd. Or m to the negative 3rd, I didn't want to do that, is 1 over m to the 3rd. So what we know about the negative exponent rules is that for any time we have a negative exponent, we basically put it in the denominator, or we take the reciprocal of it. So we flip it. So we take this and move it into the denominator. So the rule is for our integer, for any integer, any integer a to the negative, alright, the rule says to take the reciprocal of it. Alright, so the reciprocal is because we need to get rid of that negative exponent, so we want 1 over a to the n. So what I mean by that is, if we have like an example of a to the negative 3, that's going to give us 1 over a to the 3. Now it's the negative exponents, the way that I'll show you to do it makes it very simple. So when we look at these examples, we have a -2, so I'm going to circle this, and I'm going to bring it down. So if I put it into my denominator, I'm taking the reciprocal, so that becomes 1 over y to the second. Number 3, I have a negative exponent, so I'm going to circle that because we can't have negative exponents. I bring it down, so I'm going to have 1 over n to the third. Number 3, I have a negative exponent, so I'm going to circle my negative exponent, bring it down. So it's going to give me 1 over 5 to the fourth. And then we can say, well, 5 to the fourth is actually 625. And then when we look at number 4, the negative exponent is the a. So I only circle the a, and I only bring the a down. Well, so that means I'm going to have 3 times 1 over a to the third. Because I brought the a down. Well, 3 times 1, that's just going to give me 3 over a to the third. So the 3 stays in the numerator. Now the reverse of this is also true. What I mean by that is when we have a negative exponent in the denominator, if we circle it, well, it's in the denominator, we can't bring it down, so now we bring it up. So this is just going to become 1x to the third. And with number 6, circle my negative exponent, so I bring it up. So it's going to be 1a to the second. And number 7, I have a negative exponent, so I circle that. Bring it up, it's going to be 5b to the third. So if it's in a denominator, we bring it up to the numerator, and if we have a negative exponent in the numerator, we bring it down to the denominator. Now the zero exponent rule. Well, if we use the quotient rule, we have 5 to the 3 minus 3, and 3 minus 3 is 0, so 5 to the 0. And here, once again, we have m to the 2 minus 2, which is going to equal m to the 0. And now if I write this out, it's 5 times 5 times 5, and 5 times 5 times 5. Now all of the 5's cross off, but remember we're left with 1 times 1 times 1, which is 1, and 1 times 1 times 1, which is 1. Well, 1 over 1 is just 1. And then the same thing here, this is m times m over m times m. These all cross off, so we're left with 1 over 1, which is 1. So what you need to know is that 5 to the 0 is 1, and m to the 0 is also 1. So our exponent, the zero exponent rule says any number, any variable, anything raised to the 0 power is always 1. So anything raised to the power of 0 is 1. And that shows by the expanded form. When you're raising it to the 0 power, you're crossing everything off. You're just left with 1. The zero exponent rule is one of the easiest ones because it's simply 5 to the 0, 1. A to the 0, 1. Now, x, y to the 0, since this whole thing inside the parenthesis, 1. But with number 4, the only thing raised to the 0 power is that x. So that's really going to be 3 times 1 times y squared. So 3 times 1 is 3, so you're just left with 3y squared. So since the x to the 0 is 1, we can really just take it out, and we're left with 3y squared. So we looked at the zero exponent rule. We looked at the negative exponent rule, where we take the reciprocal, or if it's in the numerator, we move it to the denominator. If it's in the denominator, we move it to the numerator. And then we looked at the quotient rule, where we just subtract the exponents. So that's notes number 2 with dividing monomials.